5.3, Day 2, Trigonometric Functions of Any Angle. We're going to talk about reference angles, which are positive acute angles. Acute means that the measure is less than 90 degrees, formed by the terminal side and the x-axis. Very important. So I'm going to give you this little helpful hint to help you. If the angle falls in quadrant 1, it is already positive and acute. If the angle falls in quadrant 2, to find the reference angle, you're going to do pi minus your angle, if it's in radians, or 180 degrees minus your angle if it's in degrees. If your angle falls in quadrant 3, so that means it went all the way around here, you're going to do your angle minus pi if it's in radians, or your angle minus 180 degrees if it's in degrees. If the angle falls in quadrant 4, to find the reference angle, you're going to do 2 pi minus your angle, or 360 degrees minus your angle. So the reference angles are those angles formed with the x-axis. In example 1, we're going to find the reference angles. So for those of you who are visual, 345 falls in quadrant 4. So remember, if it falls in quadrant 4, you do 360 degrees minus 345 will give you 15 degrees. See, it's positive and it's less than 90. 5 pi over 6 falls in quadrant 2. So if it falls in quadrant 2, you do pi, because it's in radians, minus 5 pi over 6. Get a common denominator. So 6 pi over 6 minus 5 pi over 6 is pi over 6, which is the same thing as 30 degrees. So it's positive, less than 90. Part C, negative 135 falls in quadrant 3. In this case, we would do the angle minus 180, but since it's negative, we're going to add 180, which in turn gives us 45 degrees. In examples D, E, and F, you're going to notice that the angle is either larger than 2 pi or it is negative. In this case, we have to use coterminal angles. So let's first find the coterminal angle for 580. Remember, we subtract 360 because it's over 360, and that would give us 220. So 220 falls in quadrant 3. Remember, to find the reference angle, you would take your angle and you would subtract 180, which would give us 40 degrees. For E, we're going to use 2 pi, since it's in radians. You're going to get a common denominator. So we're doing 8 pi over 3 minus 6 pi over 3 gives us 2 pi over 3. 2 pi over 3 is in quadrant 2. And if the angle's in quadrant 2, remember to find the reference angle. You do pi minus 2 pi over 3, get a common denominator. 3 pi over 3 minus 2 pi over 3 gives us 1 pi over 3. And then F, this is negative, so first we have to make it positive. So we have to add 2 pi. So negative 13 pi over 6 plus 12 pi over 6 gives us negative pi over 6. Still negative, so we have to do it again. Get a common denominator. That will give us 11 pi over 6. 11 pi over 6 falls in quadrant 4. Remember, if it falls in quadrant 4, you have to do 2 pi minus your angle. 12 pi over 6 minus 11 pi over 6 gives us 1 pi over 6. So let's look at example 2. We're going to use reference angles to find the exact value of the trig functions. When you're finding exact values, you have to look at what quadrant your angle lies in to know if the sign should be positive or negative. So sine of 135 lies in quadrant 2, where sine is positive. So we know our answer is going to be positive. And to find the reference angle, if it lies in quadrant 2, remember you take 180, you subtract 135, and you get 45 degrees. So looking at the 45-degree triangle, 1, 1, radical 2, to find sine of 45, you would do opposite over hypotenuse, and we have to rationalize it. So that value will be radical 2 over 2, positive. For 4 pi over 3, that lies in quadrant 3, where cosine is negative. To find the reference angle if it lies in quadrant 3, remember you do your angle or your theta minus pi. And you have to get a common denominator. So 4 pi over 3 minus 3 pi over 3 gives you pi over 3, which is 60 degrees. So I'm drawing that triangle. 1, radical 3, and 2. So to find cosine of 60 degrees, or pi over 3, you would do adjacent over hypotenuse, but it's negative since it's in quadrant 3. And then C, negative pi over 3 falls, is negative. So first of all, we have to find the reference angle. Since it falls in quadrant 4, remember you do 2 pi, or use 2 pi, and we have to add since it's negative. And you get a I'm going too fast. Common denominator. So that'll give us positive 5 pi over 3. And that is still larger than 2 pi. But it does fall, it's not larger than 2 pi. It falls in quadrant 4. So remember you take 2 pi and you subtract 5 pi over 3. Get a common denominator. So it's 6 pi over 3 minus 5 pi over 3 gives you 1 pi over 3. So basically we are finding cotangent of 60 degrees. So let me draw that triangle. So cotangent pi over 3, or 60 degrees, would be adjacent over opposite. And you have to rationalize the denominator. And since it's in quadrant 4, it is going to be negative. All right, 2D. 14 pi over 3. Let me draw the triangle so we'll already have it. 60, 30, 1, radical 3, 2. 14 pi over 3 is larger than 2 pi, so I'm going to try to find the coterminal angle. So that gives us 14 pi over 3 minus 6 pi over 3 gives us 8 pi over 3. That's still larger than 2 pi. So I'll do it again. So 8 pi over 3 minus 6 pi over 3 gives us 2 pi over 3. Okay, so 2 pi over 3 lies in quadrant 2, where tangent is negative. And to find the reference angle in this quadrant, remember you do pi minus your angle. So again, the common denominator, 3 pi over 3 minus 2 pi over 3 gives us 1 pi over 3, which is 60 degrees again. So we're doing tangent, pi over 3, but in quadrant 2. So that'll be opposite over adjacent, but negative. So our answer is negative radical 3. And then E, since this is negative, when we find a coterminal angle, we have to add 2 pi. So negative 17 pi over 4 plus 8 pi over 4 gives us negative 9 pi over 4. So I'm going to add 2 pi again, because remember it has to be positive. Get a common denominator. Negative 9 pi over 4 plus 8 pi over 4 is negative pi over 4. And I'm going to add 2 pi again. Negative 9 pi over 4 plus 8 pi over 4 gives us 7 pi over 4. 7 pi over 4 lies in quadrant 4, where secant is positive. So, to get the reference angle in this quadrant, remember you take 2 pi and you subtract your angle, getting the common denominator. 8 pi over 4 minus 7 pi over 4 gives us pi over 4, which is our 45-degree triangle. 1, 1, radical 2. So we're finding secant of pi over 4, but in quadrant 4. Secant is hypotenuse over adjacent, which is radical 2.